Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session we have started the new chapter, that is gravitation. So in the first lecture of gravitation we discussed the basics of the gravitational force between the two objects, right? And we have solved some questions related to that. And we also discussed about the gravitational field, so due to the point mass and due to the continuous mass, right? So these are the concepts we discussed in the last class. So in today lecture number 2, so we are going to discuss the gravitational field due to the spheres and then variation of g due to height and depth. So how the acceleration due to gravity g value varies. So if the object is some height above the earth's surface, or if the same object is some depth below the earth's surface, so how the acceleration due to gravity will change. Okay, so these are our main objectives today. I just need your attention for the next 1 hour, guys. Just be with me, avoid all the disturbances around you, and at the end of the lecture it's very important to prepare your own short notes. Okay, and when you are coming to the next lecture, just revise the previous short notes and then attend the today's lectures, and whatever the questions that I am giving as a homework, so try them on your own first and take some reference questions from the other books or from PW library, your wish. Okay, so practice. So the more you practice, so the more you gain grip on the subject, and so you will be able to solve the questions easily and in time. Okay, so that's the only key to success, guys. Practice, revision. Okay, so analyze yourself. If you are preparing the same way as you prepared yesterday, then your preparation strategy is completely wrong. You should change your preparation day to day. Okay, so what mistakes I have committed yesterday, so today you should not commit those mistakes. So you have to rectify them, change your strategy, and again work on your new things, new solving skills, and improve yourself, and again analyze. So like that you should proceed, guys. So you can crack any competitive exam with this. Okay, just believe yourself and believe the teachers. Okay, chalo. So without wasting much time, let's get into the topic. So today the first let's see the question. So what's the question says? See here, guys. So try to solve this question on your own. So what's the question here? Gravitational field at the center of a semicircle formed by a thin wire of AB of mass m and length L is. So here first thing is, it's a wire is bent in the form of a rod is bent in the form of a semicircle. So we already know the gravitational field, so due to the continuous mass distribution, which is gm by r square pi into 2 sine phi by 2, so where phi is the angle here for the semicircle. So the phi is equals to pi, right? So here you take it in the radians, here radians, and here degrees are radians. Consider here degrees are radians. Okay, so then see, so the electric field E is equals, sorry, not gravitational field E is equals to, so gm by r square. So for the semicircle, so this pi is equals to pi, so 2 into sine pi by 2. So in place of pi I can write pi by 2, so which is gm by r square pi. So this is sine 90 is 1, so 2. So check these options. Here it's given in terms of the length. See, what is the length of this rod for the semicircular arc? So the perimeter, its perimeter will be the length of the wire, or the length of the rod, we can say length of the thin wire will be L is equals to pi r, the perimeter of the semicircle. From here, so let me eliminate this r value. So this r is equals to L by pi, r is equals to L by pi. So then 2 gm by, so r square, which means L square by pi square into pi. So pi gets cancelled. So it will be 2gm by 2gm pi by L square. 2gm no, not this one. Gm by pi L, no. So 2gm pi by L square along x-axis, and same options along x-axis and along y-axis. Magnitude is same. So now see, the magnetic field will be obviously in this direction. Due to this element, it will have two components. One is horizontal, one is vertical. So the horizontal one here and here, the horizontal one of these two gets cancelled. So the vertical components will be added. So the net gravitational field will be vertical in along the y-axis. So option 4 is the correct one, guys. Clear? Chalo, simple question. So let's move further. So what's the question says here? If the mass of the moon is m by 81, where m is the mass of the earth, find the distance of the point where gravitational field due to earth and moon cancel each other. That means they are asking about the null point, right? So from the center of the moon, given the distance between the centers of the earth and moon is 60 r, where r is the radius of the earth. So the simple question, see, we already know there are two masses here. One is a moon, the other one is a earth, right? So the distance between these two is 60 r. Now, so if we have to find the null point, so what we do? So from the smaller mass at a distance x, right? So what is that x distance formula? We already discussed in the last class, which is root m1 by root m1 plus root m2 into, so the total distance L between them, the total distance. So here the smaller mass is the moon and the larger mass is the earth, right? So in place of small m, so substitute m by 81 by, so here root m by 81 plus root m into, so what's the distance? So it's a 60 r, right? Chalo. So now let's do the calculations. So the distance x is equals to, so we can write let's write root m, you can take it out, so that in the numerator I can write 1 by 9 root m, I am taking it out. So here also root m, you can take it out, so and cancel in the numerator and denominator. Here root 1 by 81 is 1 by 9 again, plus, so here 1 will be left, so into 60 r. So now let's do the simple calculations. X is equals to, so here 1 by 9, here also 9 is the LCM, so that 1 time plus here it goes 9 times, so into 60 r. So from here, so the x is equals to, so 9 cancel, 1 by 10 into 60 r. So here 0 cancel, x is equals to 6 r. So at a distance x is equals to 6 r, so the net gravitational field will be 0. So this distance is from where? From the moon. Okay, so from where they are asking? So cancel each other. See here, find the distance of the point where gravitational field due to earth and moon cancel each other from the center of the moon. From the moon only they are asking. So 6 r. So if they ask from the earth, it will be 54 r. If they ask from the earth, so it will be 54 r, because this is 6 r, right? This will be 54 remaining. Done? Clear, guys? Understood this point? Chalo. So just note this down. I'll just have some water. Chalo. Next. So now the gravitational field due to uniform circular ring at a point on the x-axis. Let's suppose this is a uniform circular ring. So on this uniform circular ring, so at a distance x, this is a uniform circular ring. So at a distance x, you are finding the gravitational field. So again the same thing we do. So we cut the small part here. So what is the gravitational field due to that point, and we cut some other small part here. So we find the gravitational field due to that, and then we integrate all these. So we are not going for the derivation. Simply you can write, so the gravitational field at point P is equals to, so GMR by r square plus r square whole to the power 3 by 2 gmr by, so where m is the mass of the ring and r is the radius of the ring. So this small r is the distance from the center of the ring to the point where you are finding the gravitational field. So this small r is the distance from center of the ring to the point where you are finding the gravitational field. Okay, so this is the gravitational field here. So if you want to find what is the force there, you can simply multiply that mass into the gravitational field. Okay, so this formula everyone should remember, guys. Okay, so again in the electric field, so the electric field due to the uniform circular ring of mass charge q and radius r, so you will substitute, you will just compare with this one, kqr by r square plus x square whole to the power 3 by 2. Okay, so simply remember this formula, it will be useful for both the chapters. Okay, done. Chalo. So what is the maximum value of the gravitational field at the axis of the uniform circular ring of mass m and radius r? See, so this gravitational field, where it will be maximum, at what distance, let's suppose at what distance from the center of the ring, so you'll get the gravitational field will be maximum. See, so to find the maxima, simply do the dE by dr is equals to 0, the condition for maxima. So if you solve this part, we'll get r is equals to, directly I'm writing the value, so the small r is equals to, so capital R by root 2. So at this distance we are going to get the gravitational field maximum. So the maximum gravitational field occurs at a distance of r by root 2, where r is the radius of the uniform circular ring of mass m. Okay, so at this distance gravitational field will be maximum. Gravitational field will be maximum. Okay, chalo. Done? Chalo. So let's move further. So hope this is visible. Shall I switch the lights off? I guess some dark light, some bright light is here. Are you guys able to see it? Hope it's fine. Yes. Chalo. So let's go further. So what is the maximum value of the gravitational field on at the axis of the uniform circular ring of mass m and radius r? See here. So first, the gravitational field formula, E is equals to gmr by r square plus r square whole to the power 3 by 2. So this is the formula. So now the E will be maximum, gravitational field will be maximum at small r is equals to r by root 2, at a distance of small r is equals to r by root 2. So now I am finding that E max value. So that E max is equals to g into m into, in place of small r I am substituting the r by root 2 value, r by root 2 whole by, so here r square, what is r? R by root 2 whole square, right? Plus here let me write r square means, so let it be r square itself whole to the power 3 by 2, whole to the power 3 by 2. So from here, so let's write, so gmr by, so root 2 into, so root 2 I am bringing it down, so here r square by, so what is this one? Root 2 whole square is 2 plus here r square whole to the power 3 by 2, right? Chal. So next, so let's do one thing, do the simple calculations. So here we have gmr by, so root 2 into, so what we can take common here, so r square, see here, so let's do one thing, r square into, again inside I am taking r square out, so that 1 by 2 plus 1 whole to the power 3 by 2 will be left again. So let's do one thing, so then I can write gmr by root 2 into, So I am splitting this 3 by 2 to this one and this one. So r square whole to the power 3 by 2 into, so here 1 plus 1 by 2 plus 1 by 2. So 1 by 2 plus 1, which is 3 by 2. So 3 by 2 whole to the power 3 by 2. Okay, chal. So here square 2 gets cancelled. GMR by root 2 r cube, root 2 r cube. So into square root of, so let me write this part as, so 3 by 2 into 3 by 2 into 3 by 2. So what does it mean by 3 by 2 whole to the power 3 by 2? So we can write root of 3 by 2, 3 by 2, 3 by 2. Yes, chal. So from here, so let's cancel 1r from here. So gm by root 2 r square into, so I am bringing, so instead of these two, we can take one out into, so root of 3 by 2. So if you send this 2 to upside, so 2 gm by 3 root, or else you can write, so in the options we have 3 root 3, 3 root 2. So okay, fine. So chalo, so let's do one thing. So this root 2, so and 1 root 2 gets cancelled here, and then so 3 root 3 r square, so 2 we sent it upside, yes, 2 gm by 3 root 3 r square. So 2 gm by 3 root 3 r square. Here this step you understood, guys. Here root 2 and this root 2 gets cancelled, and this 2 will go up, so that 2 gm by, here 3 is left and root 3 is there, 3 root 3 and r square. Clear? Fine? Done? Sure. So good. So next, so the graph of E versus R on the axis of a ring. So see here, first on the axis of the ring, the formula for gravitational field is ZMR by r square plus r square whole to the power 3 by 2. Okay, and then so this E will be maximum, this gravitational field will be maximum at r is equals to r by root 2. Yes, and then this is the first point, second point, and third point, that E max value will be, so 2 gm by 3 root 3 r square. So this is a E max value. So it occurs at a distance of r by root 2. Fine. So if you draw the graph of E versus r, so the gravitational field will be maximum at a distance r by root 2, and then if the r tends to infinity, so if the r tends to infinity, so the denominator value will become very, very large, so then E almost tends to 0. The gravitational field almost tends to 0. So here also, this side also, if r at the center, if you substitute at center, so then again it tends to 0. Clear? Understood this point, guys? Everyone? Chal. So this is a graph you should remember, important one. Done. Chal. So now the gravitational field due to uniform spherical shell or halo sphere. Uniform spherical shell or halo sphere. So if you are finding the gravitational field outside this sphere, halo sphere, so then the gravitational field formula E is equals to gm by, so if you are finding at a distance r from the sphere, halo sphere, so it's E is equals to gm by r square. E is equals to gm by r square. So here you can write E is inversely proportional to r square. E is inversely proportional to r square. Okay, and inside the shell r less than r, so the gravitational field will be 0. Inside it will be 0 and outside it is gm by r square. So if we have to find case 3, let me write here case 3. So on surface, at the surface, let's write at the surface. So at the surface you can write small r is equals to capital R, it will become. So in place of small r you can substitute the capital R. So the gravitational field will become gm by r square. So this is at the surface. Okay, so this is inside, this is outside, this is inside. Okay, clear this part? Just you have to remember the formulas here. Okay, so if you draw the graph of E versus R for the spherical shell, so the first thing is E inside 0, E outside gm by r square, and then E on the surface gm by r square. Okay, so then see here, so if you draw the graph now of E versus r, this is the E versus r graph if we draw, so how it will be? Inside it is 0, so inside, so if you consider this is the spherical shell, so this is the spherical shell, so inside till here it is 0, so then inside here it is 0, and outside it is inversely proportional to r square. Outside it is inversely proportional to r square. Clear guys? Understood? Chal. Next. So now let's do to the solid sphere. So for the solid sphere, so the outside formula it remains same. So the E outside will be equals to, so gm by r square, gm by r square. So where the gravitational field is inversely proportional to r square again, outside also. So but inside it's not going to be 0, because inside the mass lies. Previously inside there is no mass, shell it is, hollow sphere, so there is no mass, that's why there is no gravitational field. But outside, inside of the solid sphere there will be mass, so that there will be gravitational field. Okay, so that gravitational field inside is equals to gmr by r square. So the gravitational field is equals to gmr by r square, where, so this gravitational field inside is directly proportional to r. So now if we have to find at the surface, so let me take the case 3, so where at the surface, so you guys can do it yourself. So here at the surface, so the small r is equals to capital R, the small r is equals to capital R. So the E at the surface is equals to, so in the inside formula you can simply substitute, so gm capital R by r square, so square r cancel, so at the surface it's going to be gm by r. Clear? At the surface it's going to be gm by r. Hope the formula is clear guys, everyone. Done? Chalo. Done? Chalo. Chalo. So I wrote the graph for graph of E versus R. See, so the E inside first, which is equals to gm r by r cube. Sorry, I wrote r square here. No, sorry guys, here r cube it should be, my bad. Here it should be r cube by, sorry, very sorry. So you just change this one, r cube it is. Okay, so here also r cube you can write. R cube, and here r square, so one r will be cancelled. So here inside it is r cube, and outside gravitational field is gm by r square, and on the surface it's going to be gm by capital R square. Okay, so this is the formula. So here if you observe, inside it is directly proportional to the distance, and outside it is inversely proportional to the square of the distance, and then on the surface it's r square. So here inside it is directly proportional. If you draw the E versus R graph, so inside it is directly proportional. Here E is directly proportional to R, and then at the surface it will be maximum. At the surface it will be maximum, right? And then outside again it is inversely proportional to R square. Done? Clear concept, simple one. So remember these graphs. So these questions were asked directly in JEE mains as well as NEET also previously. So let's see the questions. So this is the previous year question only, NEET or JEE. So which one of the following plots represents a variation of gravitational field on a particle with distance r due to thin spherical shell? So see here, thin spherical shell means, so the halo sphere. So which means inside 0, outside it is inversely proportional to r square. Inside it is directly proportional, not this option. Inside here it is 0, outside it is inversely proportional. So this can be correct. So here inside it is constant, no. So inside it is directly proportional, no. So inside it should be 0, outside it is inversely proportional to r square. Done guys? Sure. Next, so let's go for the next one. So the acceleration due to gravity. So the acceleration due to gravity. So let's suppose if an object is placed near the earth surface, if an object is placed near the earth surface, so then that object will experience some force. So that force is called the gravitational force, right? So what is that acceleration due to gravity that we are going to find out? So first of all, the gravitational force between that object and the earth will be, so the earth mass I am considering it as capital M. So you have placed a mass M on the earth surface. Sorry. So then the gravitational field Fg will be equals to Gmm by, so the distance r square, Gmm by the distance r square. So we know that this object will be attracted towards the ground. So with some force, this object, so I'll write here. So the object placed on earth surface, will be attracted towards earth with force, gravitational force. So what is that gravitational force? So that object mass into, so it will be accelerated towards the earth, so which is ma. So now in place of this mg, so I can write ma, right? So Gmm by r square. From here, so shall I write, so this a is equals to, for a body which is placed at the earth surface, so that acceleration due to gravity will be equals to, a is equals to g, that acceleration is equals to g, acceleration due to gravity. So in place of a I can write g, so Gmm by r square. So from here small m cancel, so here g is equals to Gm by r square, g is equals to Gm by r square. So this formula you should remember guys. So where g is the gravitational constant, universal gravitational constant. So the g value 6.67 into 10 to the power minus 11 Newton meter square per kg square. And then so the mass of the m is a mass of the earth, m is a mass of earth, so which is given as 6.4 into 10 to the power 24 kg. Okay, and then so the r is the radius of the earth, r is a radius of earth, so where it's considered as 6400 kilometers r. So we can also write it as 6.4 into 10 to the power 6 meters, 6.4 into 10 to the power 3 meters, sorry, 10 to the power 6 meters. So this is the radius. So if you substitute all these values, g value, m value, mass of the earth, and then radius of the earth, so then you get the g is equals to 9.8 meter per second square. So 9.8 meter per second square. This we take it as a standard value, right, in all the questions. Done? Understood this point guys, everyone? Chalo. So let's move further. So what will be the formula of mass of the earth in terms of GRG? Okay, so we know that the acceleration due to gravity is equals to gm by r square, gm by r square. Now we need the mass. What will be the formula for mass of the earth? M formula. So the M is equals to gr square by capital G. So gr square by capital G. Option 2 is the correct one. Yes. So the mass of the earth formula. So gr square by capital G. Done. So now see, a spherical planet has mass mp and diameter dp. So then if the particle of mass m falling freely near the surface of this planet, will experience acceleration due to gravity equal to, so will experience acceleration due to gravity equals to, see here. So we know that the acceleration due to gravity g is equals to gm. In terms of density they gave a, so what's in terms of mass only they gave. Okay, so let's write the acceleration due to gravity they asked. So F is equals to g m1 m2 by the r square, right? So here let me write, so the acceleration due to gravity, so which is a spherical planet has mass mp and diameter dp, and a particle of mass m falling, so particle of small m mass into the gravitational is equals to, so g into, so mass of the planet is mp into, so what's mass of the small particle, small m, by, so diameter dp, so we need the radius here, right? So this distance is going to be radius, so dp by 2 I will write whole square. So then, so this 2 square, 4 will go up, so gmp m by dp square. So they are asking acceleration due to gravity, right? So here mg, so mm gets cancelled, so the small g, the acceleration due to gravity will be 4 gmp by dp square, 4 gmp by dp square. Only they are asking acceleration due to gravity, so this will be the correct option. Okay, so don't take this one 4 gmp, again don't put the small m mass because mm gets cancelled. So if it is falling near the earth surface, we take the mass of the earth into, so that particle mass, right? Previously if it is falling near the earth surface, so mass of the earth and that particle's mass. So here it is falling near some other planet, so that planet mass and that particle's mass. Okay, so that particle mass into it experiences a gravitational force, so g. Clear? Chalo. So let's take the next question. So what's the question says here? See, the acceleration due to gravity on the planet A is 9 times the acceleration due to gravity on the planet B. A man jumps to a height 2 meters on surface of the planet A. So what is the height of jump by the same person on the planet B? Simple question. See here. So we can write like, so the acceleration due to gravity on the, let's say this is the planet A, here the planet B. Okay, so see here. So let the acceleration due to gravity on the planet B be g. So and that the acceleration due to gravity on the planet A is 9 times that of, so 9 times the g. So man jumps to a height 2 meters on planet A. So here height is equals to 2 meters. So what is the height jump by the same person on the planet B? So let it be h dash is equals to how much? So the simple thing, so we know that the h is equals to u square by 2g. H is equals to u square by 2g, the maximum height reached by a body. Now, so if the person jumps with the same speed, so here they did not mention about the speed. So if the person jumps with the same speed, so I can write, so the h is inversely proportional to g here. The h is inversely proportional to g, we can consider. Yes, So from here, so the height of B by height in the person A is equals to GA by GB. That's it, inversely proportional, right? So we need the height of jump by the same person on the planet B, which is HB we required. HA is 2 meters. So GA, what is GA? 9G. And what is GB? GB is G. So here G gets cancelled. So the HB is 9 into 2, 18 meters. 9 into 2, 18 meters. Okay na? Clear guys? Understood the concept? Chalo. So let's move further. So see this formula you can also write. So the acceleration due to gravity. So what is that acceleration due to gravity? G, small g is equals to gm by r square. So consider the earth has, this is a earth. So earth is considered as a solid sphere. Earth is considered as a solid sphere guys. So for this solid sphere, it will have some radii r. So it has some density rho also. It will have some density rho. So what is the density of that earth now? The density is equals to mass by volume. The density is equals to mass by volume from here. So the mass of the earth can be written in terms of density and volume. So the mass is equals to density into volume. So as the earth is a solid sphere, so we can consider the volume of the earth will be 4 by 3 pi r cube. Okay. So now let me write the acceleration due to gravity in terms of the density of earth. So the G is equals to G into, so in place of mass of the earth, I am writing, so the density into 4 by 3 pi r cube by r square, right? So here r square cancel. So the G is equals to, small g is equals to G into rho into 4 by 3 pi into r, right? So one r will be left in the numerator. So if we write properly, so 4 g pi rho r by 3. So this is in terms of the density. So what is this one? The acceleration due to gravity in terms of the acceleration due to gravity in terms of density of earth. In terms of density of earth. Clear guys? Chalo. So done. So next let's move further. So what's the question says here? The acceleration due to gravity G and the mean density of the earth P are related by which of the following relation? So just now we discussed. So the acceleration due to gravity small g is equals to 4g pi rho r by 3. So here they are asking rho formula. So what is rho? Rho is equals to 3g, rho is equals to 3g by 4g pi r. So rho is equals to 3g by 4g pi r. Option 1 is correct. So here r cube, here 3g, here 4 pi g r cube. No. Okay. So this is the formula, direct formula based question. Done? Chal. Next. So let's go for the next question guys. So what's the question says here? Imagine a new planet having the same density as of the earth. So here two planets are there. One is earth, the other one is some other planet. So let's say write it as planet. So they both have the same density. So rho and rho. So but it is 3 times bigger than the earth in size. So 3 times bigger than the earth in size means if the earth has radius r, so the new planet will have the radius 3r. Yes or no? Clear? Chalo. So if the acceleration due to gravity on the surface of the earth is g, on the earth it is g, so then that on the surface of the new planet will be. So G dash is equals to how much? So simply, so they gave their densities also. Let's write in terms of density. So what's the density formula we have? So what's the density G in terms of density? 4 pi G rho r by the 3 value, by the value 3, right? So from here you guys can observe that, so 4 is a constant, pi is a constant, acceleration due to gravity G is the constant, and rho is same for both, and 3 is also constant. So this whole value is going to be constant. From here, shall I say that the G is directly proportional to the radius of the planet? So here, if the if the radius of the earth is r and the acceleration due to gravity is g, so if the radius of the planet is 3r, so its acceleration due to gravity will be, so 3 times that of the acceleration due to gravity of the earth. So it will be 3 times that of the acceleration due to gravity of the earth. Yes or no? Simple logic. Just you have to understand the concept here. Okay. Chalo. So option 4 is a correct one. Done. Any doubt here? Any doubt, guys? Chalo. So let's move further. So just have the look at the question and solution what we did. So the density of the newly discovered planet is twice that of the earth. So again 2. So one is earth, so the other one is a planet. So they are saying that the density of the newly discovered planet is twice that of the earth. So let the earth has density rho. So then the new density of the planet is 2 rho. Fine. So the acceleration due to gravity at the surface of the planet is equals to that of the earth. So planet and earth, so they both have the acceleration due to gravity same. So if the radius of the earth is r, so then what is the radius of the new planet will be? So r dash is equals to how much? So let's do the same simple calculation. So let me write the acceleration due to gravity for the earth formula in terms of density. I'll write. So for the earth, G is equals to, so 4 G pi rho r by 3. So here radius of the earth. So and for the planet, if I write the same formula, so G dash is equals to, here also G dash is equals to G only. So let me write G only because they both have the same acceleration due to gravity. So G is equals to 4 is a constant, G is a constant, pi is a constant, but the density of the planet is 2 times of this one, 2 times that of rho, and then so the radius is r dash by, so the value this one is constant. So let's do one thing, let it be equation number 1, let it be equation number 2. So let's divide this. So equation 1 by equation 2 if we do, so 1 by 1 on the LHS side is equals to, so I can simply write this whole thing. If you want you can write that. So 4G pi rho r by 3 by 4G pi, so 2 rho r dash by 3. So 3 cancel, 4G pi cancel, rho cancel, right? So here 1 by 1 is 1 is equals to, so what's left here? R by 2 r dash, right? So from here I'll write, so 2 r dash is equals to r. So we need r dash. So r dash is equals to r by 2 simply. R dash is equals to r by 2. So which is option 4 is the correct one, guys. Clear? Simple one again. Chalo. So let's move further. So now let's go for how the acceleration due to gravity changes with height, with the depth, and due to the shape of the earth, and due to the rotation of the earth. So these two we'll cover in today's session. So the remaining two, so I'll take it in the next session. Okay. So if you see, this is the earth surface. So consider this is the earth surface. So the first two conditions are, So if it is of radius r, if you place the object near the earth surface, the acceleration due to gravity will be g. Yes or no? So that g will be equals to gm by r square. So we take this value as 9.8 meter per second square. But if this object is very far from the surface of the earth, so at a height h, so this height h it means so very far distance, like some 2000 kilometers, 2500 kilometers, or some 3000 kilometers, like that. So it's not just 100 meters above the ground or 200 meters above the ground or 1 kilometer above the ground. No. Okay, up to 10 kilometers we can consider it as, so it's on the surface of the earth only. Okay, so if the very far distances, for very far distances above the ground, so how the g value changes? And similarly, so at the depth h below the earth surface, so this is the earth surface, at a h from the surface of the earth, how the acceleration due to gravity changes. So I can say that, so okay, let's derive so that you can get the idea. So consider here, this is at the height h above the earth surface. So this is the center of the earth. Okay, so then this will be the radius of the earth r. So here the object is placed at a distance small r from the center of the earth. See, so while writing the formula f is equals to g m1 m2 by r, so this distance is center of one body to the center of the another body. This r is a center to center distance. Okay, so remember that point. So here simply I can write it like, so the total distance r is equals to, so the radius of the earth plus the height h, the radius of the earth plus height h. Yes or no? So if this object is placed above the ground, now there will be some force between these two. There will be the force of attraction between these two objects, between earth and the object of mass m. Let's say this has mass m. So the force of attraction Fg is equals to, so we can write, so g into mass of the object, sorry, mass of the earth capital M, so mass of the object small m, by, so what's the distance between those two? R square. So let it be the equation number 1, the first equation. And in the second equation, so this object will be pulled towards the earth, so with new gravitational force, like with new acceleration due to gravity, because if it is on the surface of the earth, it will be attracted towards the ground with the acceleration due to gravity, but it is not on the surface of the earth now, so it is at some far height. So now the force with which it attracted towards the ground is, let's say, mg dash is equals to mg dash. Yes or no? So that force Fg is equals to, I can write mg dash. Yes or no? So from here, g m by r square. So better, let's write this one. So here m cancel, so that I got g dash is equals to gm by r square. So the new acceleration due to gravity is gm by r square we got, because the object is not placed on the surface of the earth, it is placed at some height from the ground, so that the acceleration due to gravity also changes. What is that acceleration due to gravity? G dash. So now let's consider this as a equation number 1. So now we already know that the acceleration due to gravity on the surface of the earth is gm by capital R square. Don't get confused between these two. This is a new acceleration due to gravity, because the object is placed far above the earth's surface. So this is the acceleration due to gravity when the object is placed on the surface of the earth. So consider this is the equation number 2. So now, so let me write here. So divide equation 1 by 2. So g dash by g is equals to gm by r square by, so gm by r square, right? So gm gets cancelled, so I can write g dash by g is equals to, so this r square will go up by r square, right? So let me do one thing. So that g dash will be equals to r square by, So in place of the small r square, so let me write r plus h whole square. So let me write r plus h whole square. Small r is equals to r plus h whole square, right? So from here, the g dash is equals to r by r plus h whole square. R by r plus h whole square. Yes. So now let me write it further. So we can write that g dash by g. G dash by g is equals to, so we can write here r square by r plus h whole square, right? Chalo. So then do one thing, g dash by g is equals to, so let me write, so take r by r plus h whole square we can write. So we can write g dash by g is equals to, take r out, take r common in the denominator also. So r by, so r if I can take common, 1 plus h by r, this will be, so whole square, right? So here r gets cancelled. So the g dash by g is equals to, so let me write here, so 1 by 1 plus h by r whole square, 1 plus 1 by h r 1 by 1 plus h r whole square. Or we can also write g dash by g is equals to 1 by, so this is, okay, so just let it be. So this is the final equation you can take. Clear? So or you can write g dash is equals to g times, so 1 plus 1 by 1 plus h by r whole square. So this is a new acceleration due to gravity, guys. So this is a new acceleration due to gravity. Clear? Understood? Clear? Done. So we can also write it as simply 1 whole square means 1, right? So g dash is equals to g by 1 plus h by r whole square. This is also fine. So now the acceleration due to gravity is increasing or decreasing? So see here, g by something, g by something. This value cannot be 0, right? So it will be obviously greater than 0. So that it will be obviously some greater than 1, I can say. 1 plus this value is getting added. So 1 plus something. So that means g by 1 point something like that. So that if you divide some quantity by, so more than 1, so obviously its value gets decreases. So the g dash, so the new acceleration due to gravity is getting decreases. It decreases as we go away from the surface of the earth. So in the first case, so the acceleration due to gravity decreases. The acceleration due to gravity decreases. Clear? Understood, guys? And then, so one more important note here. So the important note, see, we have got, so the g dash is equals to g into g by 1 plus h by r whole square, right? So if the object is, if the object is placed near the earth's surface, near the earth's surface, so that is, so some 5 kilometers, some 1 kilometer, or some 10 kilometers, so like that. So then we can write this expression as, so the g dash is equals to g into 1 minus 2h by r. So g dash is equals to g into 1 minus 2h by r. So this expression also very important. So if it is placed some distance, so g dash is equals to g into 1 minus 2h by r. So note this point, important, guys. Done? Everyone? Chalo. So let's take the questions now. So let me write the formulas. So I'll write here once. Above the earth surface, above the earth surface at a height h, at a height h. So the actual formula always valid is this one. G dash is equals to G by 1 plus h by r whole square. So this is always valid. Okay. So if h is far less than the r, if h is far less than the r, so this is the case where the h is far less than the r, so then you can use the binomial expansion here. So in that case, so the G dash will be equals to G into, so 1 minus 2h by r. So this he has studied it in the math, right? So he has studied it in the maths. So binomial theorem. Done? Clear? Chalo. So let's go for the at depth h below the earth surface. See, so generally the earth is considered as, so generally the earth is considered as the solid sphere. Solid sphere. Okay. So now you are placing the object, so which is of mass m, so at a height h from the surface of the earth. So now the center of the earth will be somewhere around here. So the radius of the earth will be this one. Now the distance between the object and the center of the earth is going to be small r. Yes. So from here the small r is equals to, so the radius of the earth minus, so this height h. So this height is h from the below the surface of the earth. But when you are writing the formula, it should be between these two. The distance between these two you should consider. Okay, so always keep it in mind. So we already know that, so the E inside is equals to gmr by r cube. So what is the gravitational field? It's nothing but the acceleration due to gravity. So yes or no? So the acceleration due to gravity, so the new acceleration due to gravity inside the earth is equals to gmr by r cube. Let it be equation number 1. Now, so we already know that g is equals to gm by r square. So let it be equation number 2. So from here, so let me write, so the g dash by g is equals to, so gmr by r cube whole by, so gm by r square. So from here gm gets cancelled, so r square gets cancelled. So the g dash by g is equals to, we left with r by r. Yes or no? So what's the thing that is left? R by r. So now let's write, so the g dash by g is equals to, so what is this r? R is r minus h by r. R minus h by r. So then, so let's do the simple calculations here. So we can write the g dash by g is equals to, so r by r is 1 minus h by r. Right? So from here that g dash is equals to g into 1 minus h by r. So that g dash is equals to g into 1 minus h by r. So this is at a height h, or at a depth h below the earth surface. So in some of the reference books, so at a depth d below the earth surface they write. So if it is d below, so g into 1 minus d by r you can write. D into g into 1 minus d by r. Clear? Understood this, guys? So just simply let me write here. At height h above earth surface, and then at depth h below earth surface. Okay, chalo. So here we write this one. So the gravitational field, so here, sorry, not gravitational field, G is equals to gm by r square, the actual one. So now the new gravitational acceleration due to gravity will be equals to, so g into g by 1 plus h by r whole square, right? So here g dash is equals to, we can write g into 1 minus 2h by r. So when the h is far less than the r. Done. So in this particular case, so the g dash, what we got, g dash is equals to gm by r square, right? So where this g dash is inversely proportional to the r square in this case. Yes or no? So now at a depth d below the earth's surface, we have got that g dash is equals to, so gmr by r cube, where here g dash is inversely proportional to the r. So and then see here, so the g dash is equals to g into, so 1 minus h by r, g into 1 minus h by r. So now at a depth d below the earth's surface, so will the gravitational field increases or decreases? Always remember, so the gravitational field is directly proportional to the r here inside. So from center to surface of the earth, the gravitational field increases. From center to surface of the earth, the gravitational, the acceleration due to gravity, g increases. But we are finding below the surface, from surface to center, it decreases. From surface to center, it decreases. So that's what we are discussing, right, actually. So at a depth h below the earth's surface, again it decreases. But from center to the surface, it increases. From surface to the height h above, again it decreases. Understanding, guys? So let's have the basic understanding here. So let me write the new slide here again. So let me add the one slide. So this is the earth surface. Consider this as the earth. So from the center of the earth to the surface of the earth, so the g value from here to here increases. But from surface to the center, so the g value decreases. And above the surface of the earth, the g value decreases. Above the surface of the earth. Understood? Clear? Understood, guys? So now again I am writing the formulas, so just to make you understand. So g dash above height h, above height h, so g dash is equals to g by, so 1 plus h by r whole square, r. So if h is far less than the r, so we can write g dash is equals to g into 1 minus 2h by r. So now, so height h above this one, height h below, so then g dash is equals to g into 1 minus h by r. That's it. So these are the formulas everyone should remember. Done, guys? Clear the concept? Chal. So let's take the question. So what's the question says here? The height at which the weight of the body becomes 1/16th its weight on the surface of the earth. So when the object is placed on the surface of the earth, so its weight will be mg, right? Its weight will be mg. So then m is the constant here. So now if it is raised to some height, so its weight will become m into some g dash. Its weight will become m into g dash. So now this weight will be, so 1/16th of, so 1/16th of the new weight, so into, so mg into, so at some height they are asking, so g by, let's write this way. So the, as the mass is constant, so you can simply write this part. So the g dash is equals to g by 1 plus h by r whole square, right? So from here, so as mass is constant, we can simply take this as 1/16 of the g is equals to g by 1 plus h by r whole square, right? So here G gets cancelled. So by comparing, you can write like, so 1 plus h by r whole square is equals to 16, right? So 1 plus h by r is equals to plus or minus 4 here. So if I take 1 plus h by r is equals to 4, so then h by r is equals to, so this will be I can 1 plus h by r is equals to 4, and 1 plus h by r is equals to minus 4 you can take, right? So then if I send it to that side, h by r is equals to 3. So from here h is equals to 3r. So this is one option, r. So h by r is equals to minus 5. So h is equals to minus 5r. So the height cannot be negative. So this can be ignored. So the h is equals to 3r. Option 1 is the correct answer. Clear guys? Done? Sure. So try this question. So try this question on your own. The body of weight 72 newtons moves from the surface of the earth to a height half of the radius of the earth. Okay. So then the new gravitational force exerted on it will be. So again the same concept. Again the same concept you can take. See, the new gravitational force we have to find. So mg dash. So we know what is the weight. Mg is given. The original weight mg is 72 newtons. So it raised to what height? So this height is equals to, so height is equals to half the radius of the earth. So simply substitute it in the formula. Same concept, just substitute it in the formula. Same previous concepts. Find the g dash, which is equals to g by 1 plus h by r whole square. From here g by 1 plus h. What is h? R by 2. So r by 2 by r, which is nothing but r by 2r I am writing. Okay. So then whole square g dash. So from here g dash is equals to, so g by, so r cancel, 1 plus 1 by 2, which is 3 by 2 whole square. So g dash is equals to, so from here I can write, so the new weight they are asking, so I am multiplying either side by m. So mg into, so this will become 4 by 9. Let's write 4 by 9. So what is mg? Initial weight 72 into 4 by 9. So this is 8 times 8 into 4, 32 newtons is the new gravitational force exerted on it. So which is option 2 is the correct one. Simple questions these are all. Okay. So the next question, a body weighs 200 newtons on the surface of the earth. How much it will weigh? Half the way down to the center of the earth. Half the way down to the center of the earth. So initial weight is given. So mg is 200 newtons. Okay. So now the g dash will be equals to g into 1 minus h by r below the earth surface. Half the way down to the center of the earth. So half the way means h is equals to r by 2. So h is equals to, in place of this, r by 2. So which is r by 2r. Right? R gets cancelled. So the g dash will be equals to g into, so 1 minus 1 by 2. So which is 1 by 2. So here multiply either side by m. So which is mg dash is equals to mg into 1 by 2. So what mg dash is the new force we required. So which is equals to mg is 200 by 2. So which is nothing but 100 newtons. Which is nothing but 100 newtons is the correct answer. Simple question. Right? Chalo. So let's take this question. The acceleration due to gravity at a height h above the earth is same as at the height d below the surface of the earth. See here, at a height 1 kilometer. So the acceleration due to gravity, so above the surface 1 kilometer is equals to, so same as of the accelerated due to gravity d below the surface. Right? So 1 kilometer means h is far less than the r here. You can consider the formula. So g into 1 minus 2h by r is equals to d below, which means g into 1 minus d by r. Yes. So from here g gets cancelled. So we can write, So 1 minus 2h by r is equals to, so 1 minus d by r. So 1 cancel, minus minus cancel. So the 2h by r is equals to d by r. So here r cancel, d is equals to 2h. So what we required actually, so d is equals to 2h. So 2 into, so what is the height h? 1 kilometer above the d is equals to 2 kilometers is the correct answer. So option 4 is the correct one. Clear? So all the questions are simple. These questions are directly framed. Okay, done. Chalo. So let's move further. So starting from the center of the earth, see, starting from the center of the earth having radius r, the variation of g from center to the surface it increases, right? So center to surface g increases, right? So from surface to some height h, so it decreases. So first from center it's constant, no, center to the surface it increases, and on the surface it becomes maximum. So then again it decreases. So this is correct answer. So then it increases and then it decreases. So it decreases linearly they gave. So here increases, fine, decreases. So here increases exponentially, no. See, so check the options 2 and 3. So the, see, it will not decrease linearly, so it will decrease something like this. Option 3 is the correct one, guys. You have to check between these two, because linearly increases, g is directly proportional to r from the center of the earth to the surface of the earth. So but after that it decreases, not linearly. So some like this. Okay, clear? Chalo, next. So the dependence of acceleration due to gravity g on the distance from the center of the earth assumed to be a sphere of radius r, uniform density as shown in the figure. So again same question, from center to, see here, from center to surface it increases. So then from the surface to height h above it decreases. Again same question. Done? So in the lecture number 3, so we'll discuss about, so how the g value changes due to the shape of the earth and due to the rotation of the earth. Okay, so till then keep studying. All the very best. Bye, take care.